Hello everyone, my name is Amaziro Dupada, and in this session, we are going to see applications of differential equations in mechanical discipline by taking the concept of Newton's law of cooling. This is the concept you have to understand before understanding how to do a particular problems in differential equations under mathematics. So here the concept is, let me take an object firstly. This is an object having some temperature called theta, and this object is surrounded by an environment. We can say this is called ambiency. At this temperature is called theta naught. It means theta naught is equal to ambient temperature. Ambient temperature or surroundings temperature. Like now, object temperature is theta, surroundings temperature is theta naught. Now, if the difference between theta and theta naught exists, then automatically heat transfer will be there from object to ambient or ambient to ambiency to object based on the value. If theta is greater than theta naught, heat will transfer from object to surroundings. If theta is less than theta naught, then heat will transfer from surroundings to the object. Now, when heat is transferring, then what actually generally happens is temperature of the object will change. Now, that is the thing what we are taking. So, temperature of the object means theta. Now, temperature of an object theta is depending upon time t, because over a time this is changing. So now d theta by dt, it means rate of change of temperature of an object is depending upon is depending upon or it is directly proportional to the difference in the temperature between temperature of an object and temperature of surroundings. So d theta by dt is directly proportional to theta minus theta naught. Why? Because rate of change of temperature of an object is depending upon is directly proportional to the difference in the temperatures between the object and the surroundings. So d theta by dt is directly proportional to theta minus theta naught. That implies d theta by dt, d theta by dt is equal to minus k into theta minus theta naught. This is the, here k is constant, you can say k is constant. So this is the theory behind the problems what we are going to see in now. So directly let me go to solve your problem. A body originally at 80 degrees centigrade cools down to 60 degrees in 20 minutes. The temperature of air being 40 degrees. What will be the temperature of a body after 40 minutes from original? From original means from zero time, like. So let me take the conditions now. Let me have an object called body. This is called surroundings. So body temperature I represent with theta, as we have seen in theory. So body temperature originally at how much? Theta is equal to 80 degrees centigrade. It means at a time t is equal to 0. Cools down to 60 degrees in 20 minutes. Means theta become 60 degrees after 20 minutes. Now, what is the temperature of air being 40 degrees? It means theta naught. It means surrounding temperature. It means the ambient temperature. Theta naught is equal to 40 degrees. Now, what he is asking, what will be the temperature of your body after 40 minutes? It means what is the value of theta at t is equal to 40 minutes from 0 time. Remember, it is from original means from 0 time. It means now I need to form an equation between theta and time t, because theta is the body temperature is varying with respect to time. So if you able to give an equation between theta and t, at any value of t you can find theta value. So that is what you have to identify, or you form an equation. So how it is? We use the basic concept, the theory concept we have seen. The rate of change of temperature of an object is directly proportional to the difference between object temperature and ambient temperature. So d theta by dt is equal to minus k into theta minus theta naught. Here remember, k is constant, and one more thing is I have kept k minus sign. Why? Because I don't know whether theta is greater than theta naught or theta naught greater than theta. So in such cases, generally we put minus sign here. So d theta by dt is equal to, this is the equation. Now starting value I will put. So d theta by dt, that implies d theta by dt is equal to minus k into theta minus theta naught is fixed. How much it is? 40 degrees centigrade. So d theta by dt is equal to this much. Now the next step here I am doing, theta and d theta values I am separating. D theta over theta minus 40 is equal to minus k into dt. What I do is now I integrate both sides. I integrate both sides. So what you will get? 1 by x log x log theta minus 40 is equal to minus k integration of dt minus kt plus some constant. That constant, what I do is I take as log c. So if you bring this value this side, log a minus log b, log a by b, log theta minus 40 by c is equal to minus kt, right? So theta minus 40 by c is equal to e to the power minus kt. That implies theta minus 40 is equal to c into e to the power minus kt. That implies theta is equal to 40 plus c into e to the power minus k into t. That's it. This is the equation one. Let me say this is the actually solution. It means theta is changing with respect to time t. But here two things are, c is constant, k is also a constant. C is arbitrary constant. Here k is a real constant. So now to solve this equation, it means at any value of time, for suppose what is the question? They asked what is the value of theta or temperature of an object at t is equal to 40 minutes. If you put t is equal to 40, you cannot find theta directly because you don't know the two values. Here they are c and k. In order to find these two values, at least two initial conditions you should know. The initial conditions only that we have written in the beginning, these two initial conditions now we will apply. Theta is equal to 80 degrees centigrade at time t is equal to 0, and theta is equal to 60 degrees centigrade at t is equal to 20 minutes. These are the two initial conditions. Now I will apply to find k and c values. So apply initial conditions. apply initial conditions. So what is the initial conditions? Theta is equal to 80 at a t is equal to 0. So put theta is equal to 80 in equation 1 is equal to 40 plus c into e to the power minus k into 0. It means this total value become 1, right? So now c is equal to, directly you can say 80 minus 40. It means c is equal to 40. One equation, one value, you got it. So apply another initial condition. What is another initial condition? Theta is equal to, how much it is? 60 degrees. At t is equal to 20. It means same, you put that same, you put these values in equation 1. So theta is equal to, you put value 60 is equal to 40 plus c into e to the power, c we know that already, 40 e to the power minus k into t. 60 minus 40, 20 is equal to 40 into e to the power minus kt. It means e to the power minus kt is equal to 1 by 2. Apply both sides logarithmic. Minus kt log e is equal to log 1 by 2. So now what I want, kt. So e power log e is 1. So I want k value. So k is equal to, sorry, something is wrong, I think. T anyhow 20, you can put it. So minus k into 20 log e is 1 is equal to log 1 by 2. So my k is equal to minus 1 by 20 log 1 by 2. This you can write 1 by 20 log 1 by 2 minus 1, you can write like, now right, you can write like 2. Because 1 by 2 is 2 power minus 1, minus into minus plus. So 1 by 20 into log 2. This is the k value. This is the k value. Now you know c value, you know k value. Now equation 1 you can write theta is equal to 40 plus c into e to the power minus kt. Now equation 1 becomes theta is equal to 40 plus c means 40 into e to the power minus k value means 1 over 20 log 2 t. That's it. Now this is the new equation. Now in this, all values you know. It means at any value of t, you can find theta. At any value of t, you can find theta. Now what he is asking in the problem, at t is equal to 40 minutes, what is the value of theta? So theta is equal to 40 plus 40 into e to the power minus 1 over 20 log 2. Log 2 into t is equal to how much? 40. So now theta is equal to 40 plus 40 into e to the power minus 1 by 20 into 40. It means minus 2 log 2. So theta is equal to 40 plus 40 into e to the power minus 2 I am taking here, 2 to the power minus 2 base e. So theta is equal to 40 plus 40 into e log base e, both will be cancelled each other. So finally you will get 2 to the power minus 2. It means 1 by 4. It means 40 plus 4 into tens. It means theta is equal to 50 degrees centigrade. At theta is equal to 50 degrees centigrade at t is equal to 40 minutes. That's it, as simple as that. So here the thing is, the question is very simple. He is asking theta at a particular time. So you have to make an equation theta in terms of time t. In order to make an equation theta in terms of time t, you should know what is the concept behind it? It means how theta is changing with respect to time t. To do that, we have taken that theory. It means like body temperature theta naught is the ambient temperature, how a body temperature is changing over a time t when it is surrounded by the uh, environment or ambience, we can say, our surroundings. So that temperature is called theta naught. That's it. Thank you for watching this video.